In this section, there's one last quick thing that I want to mention about the Docker build process. This is an important thing to understand because it's what gives Docker so much performance whenever creating a new image. All right, so I'm looking at my Docker file right here. We have our 3 instructions, and as you very well know by this point, out of each one of these instructions, we essentially get a new image. So from Alpine, we get the Alpine image. From the run instruction, we get a temporary image that gets fed into the CMD instruction, which gives us another temporary image. So at every instruction along the way, we have a file system snapshot and a startup command for that image. Now, I want to show you something a little bit interesting. I'm going to go back over to my Docker file, and on the run instruction, I'm going to add a new one right underneath it. I'm going to say run apk add -- update gcc. So we're just installing a very random second dependency here. There's nothing important that you need to know about GCC. We're just installing a second dependency. So I want you to think about what effect this is going to have on our overall flow. Essentially what it's going to do is add in a new instruction right here that's going to look a little something like this. We're going to see a new one. Let's see how quickly I can do this edit. We're going to get our new instruction right there. It's going to be very similar to the image from the previous step. And it's going to have a new little program or folder or something inside of it of GCC. So essentially it is identical to the previous image, but it has this extra little program that has been added in. Let's now flip over to our terminal. I want to rebuild our image, and you're going to notice something kind of interesting. So back over at my terminal, I'm still inside of my Redis image directory, and I'm going to build my image a second time by running docker build dot. All right, so we're going to very quickly see some installation steps right here as it adds in that additional package. But I want to scroll up to the second instruction, and I want to point out something interesting up there. So we still see step 1 of 4 right here, where we do from Alpine. You'll notice that we do not see any of that like fetching image stuff that we saw the first time, because we have already fetched the Alpine image. We've already downloaded it from the Docker Hub, and so we don't have to go and download it a second time. Now, the interesting thing that I want to show you, and this is where Docker gets so much of its speed and performance from when building an image, you'll notice that during step number 2 right here, we do not see any of that stuff around running in blah, blah, blah. We don't see any fetch. We don't see any installation of dependencies. Instead, we see a single message that says using cache. So what this means is that Docker has realized that from the previous step to step number 2, nothing has changed from the last time that we ran Docker build. In other words, it knows without a doubt that it's going to get the same image from the previous step because it's the exact same instruction that it was before. And then for step number 2, Docker knows that it has already executed the command apk add update redis. It's already generated an image out of that step, this image right here. And this image has been cached and stored on your local machine. So rather than going through the process of creating another container out of the Alpine image and running apk add update redis inside that container a second time, it says, you know what, I've already done this work. I'm just going to use the image that I generated during the previous step again. But then after that, Docker correctly sees that there is a new command in play. And this is not add update redis, it's add update gcc. It sees that there's a new command right here, or a new instruction in play. And so from this point on, it decides, well, you know what? Something has changed during the build process. We probably can't use our cache anymore. And from here on out, we have to go through that process of generating a container and running a command inside the container and taking the snapshot and going through all that stuff again. Now, the interesting thing about this is that it has now executed run apk add gcc, and it has generated an image out of that instruction right there. So if we now run docker build dot a third time without making any changes to our Docker file, Docker is going to correctly see we have made no changes to the Docker file. None of these steps have changed whatsoever, and so it's going to use the cached or saved versions of each of these images in building this new one. Let's do that right now, and you're going to see it in action. So we're going to do docker build dot a third time, and you'll notice that build process went extremely quickly. So Docker correctly realized that it's already downloaded Alpine. It's realized that it already ran the run command on top of Alpine. so it's using the cached version of that image. It knows it's already done the GCC, so it's using the cached version of that, and it knows that it's already executed command Redis server on top of the output of the GCC step, and so it's using the cache there again. So the lesson to learn here is that anytime that we make a change to our Docker file, we're going to have to only rerun the series of steps from the changed line on down. As a quick example of that, let's try taking this GCC line right here, and I'm going to cut it and put it right above Redis. So even though we're still taking the Alpine image and adding GCC to it and adding Redis to it, the series of steps have changed. And so Docker is going to say, okay, well, this time we're taking Alpine and first adding in GCC. So it will use the cached version of Alpine, but it's not going to have a cached version of the GCC add to use, because the last time that it ran that, it added GCC only after installing Redis. So essentially the order of operations is different, so the cache cannot be used. So I'm going to save this file after moving GCC around, and we'll try rebuilding our image for a fourth time. So I'll do docker build dot, I'll run that, and now you're going to see, yep, it has to go through that installation process all over again because the order of operations have changed. However, it only needs to rerun the steps from the changed line on down. And so we have to rerun the entire add GCC, we rerun the entire add Redis, and we have to rerun the command Redis server. All right, so again, if you are not changing your Docker file, that's great because it means that we can use cached versions for building the image. But the real lesson to learn here is that if you ever expect to have to change your Docker file, you always want to put those changes like as far down as possible. Now, for right now, that might sound really confusing, but we're going to very quickly go through another example in a couple of videos where you'll see that by changing the order of operations inside of our Docker file can dramatically change how long it takes to rebuild our image. All right, so quick pause right here, and I'll catch you in the next section.